Mom says that every day though. Like, okay, let's see. It's probably from a while back. It's Sam Lipfield math sheets.
Sam Lipfield's math sheets from the 26th of March?
Yeah.
These three?
Yeah.
Which one first? This is quiz 9 and math corrections.
Yeah, I'm just going to look at the one that we haven't done.
Okay. Okay.
Click on just click on click on Sam's math corrections out of the three attachments. And let's just take
there's two of them.
Not number 2, just that one.
Oh, just this one on the left?
Or actually, click on number. Actually, there's only one missed problem on that one. Yeah, let's just do that and click on that. I'm just going to look and find what I need to do. Go all the way down, like, and we'll go from bottom up, because you probably...
Down from this point?
Here, just go to the very bottom of the PDF.
Okay.
Just so I can, and let's see which worksheet that was, just so we can work from the bottom up and stuff.
That is that one. I don't see a title on it. Quiz on 9.1 to 9.3. Yeah.
Okay, did we do that? We didn't finish.
I seem to remember doing a light intensity problem.
Yeah, we didn't do this. We only did question number 7, and that's it.
Okay. You tell me which one you want to do. You want to do 2?
Yeah.
Okay. See if I can figure out how to blow it up here. Yeah. Alright, let me just take a quick picture of this. So what's the general equation that fits here? If the intensity of light varies inversely as the square of the distance. So if I were to write this, the intensity of light varies inversely as the square of the distance. What is that going to be? There's a K in there. Where's the K go? K is always in the numerator or a multiplier.
Okay.
Inversely means the variable is in the denominator, and it's the square of the distance. So that's how I would write the intensity varies inversely with the square of the distance. And then all of these have a K in them, whether it varies directly or jointly or inversely. Okay, now the rest of the information they give you is going to allow us to solve for K. That's always the next step, is solving for K. So they say the light intensity is 2 foot candles at 16 feet. Well, there's 2 foot candles, and K, or D rather, is 16. And hopefully those are matching units. Who knows what a foot candle is, but at least it's got the word foot in it, and that's 16 feet, so I'm sure they are. So if you solve for k, you get 32. Now we know the specific equation. The specific equation is I equals 32 over d squared. So any problem they want to give us, we're going to use that to solve it for this problem. So it says find the light intensity at 11 feet. So what is it?
I equals 32 over 11 squared.
That's it. Just do the math and that's your answer. Round the answer to the nearest hundredth. 2 decimal places.
Okay, let me just, basically, you can just do it by like...
Going to be about 2 and change.
11 times 11.
121.
And then you can just multiply.
Well, no, not multiply. 32 divided by 121.
Yeah, I guess you don't have to do that very
Okay.
divided.
Okay.
You do 32 divided by 121.
Mm-hmm.
And then it's like point 264.
Okay. Which means it's 0.26.
Yeah, good point.
Okay. In other words, don't make your mistake in rounding off to the wrong digit. All right. What else on this page? Go down.
Number 3, I guess.
Okay. Same kind of problem, and these really are quite straightforward. You just have to learn the technique. The technique is always to write the specific or the general equation, and then you're always going to be solving for k. Okay, so let's write the general equation. When something, a variable z, varies jointly with the product of x and y, so how would I write that?
I don't remember. It's been a long time.
All right. When something varies, means equal sign. There's always a k involved. If I were to say z varied directly with x, this is the way it would look. Okay? If I were to say z varies inversely with x, that's the way it would look.
Okay.
If I say z varies jointly with x and y, in fact they say the product of x and y, but that's what jointly means. Even if they would not have said jointly, I would have still known they meant the product. That's what jointly means. So now we have our general equation. Now this general equation always applies to the wording only. Always, depending on how they word it, always produces the same general equation. What's different in one model to the next is k. K always can change. So you always have to figure k. All right, so what'd you do here? It looks like you did it right. How'd you miss it? Yeah. Is that a 9? And you're in where, I guess you can't tell where I'm pointing.
No, that's a 90. I think.
Well, you must have, you didn't give an answer. Yes,
Yeah,
you did. No, okay, here's the problem with your answer. Remember what the first step of these always is. Solve for k. And then go back to the general equation and use z, x, and y, and in place of k, put the number you solved for. That's what she wants when she says find an equation that relates the variables. I can understand why you put that and why you think that might be right. but the whole name of the game is you solve for k. In other words, I can now solve for k, right?
Yeah.
Okay, solve for it. K is equal to 3.6 divided by 720.
Yeah, that equals 0.005.
Okay, so K equals 0.005. Now what's the answer to the question?
Well, it would just be that equation.
Well, read it to me.
Would it be like just what I wrote down, pretty much?
No. It's what this is, only with the K you wrote down.
So you just put 0.005 in place of K.
Here's what you do. This is the answer she's looking for, yes. In other words, this is the answer, right there. That's not what you wrote down. What you wrote down was the z value, the x value, and the y value with an unknown k. She wants it all the reverse. She wants you to give k and write down these three values as variables for future problems. In other words, the next question might be, okay, what is z going to be when x is 12 and y is 120? And then you would be able to calculate what z was. So this is called the specific equation. This is called the general equation. You always start with the general equation. It is determined by the words only. In other words, the general equation is determined by that. No numbers. That determines the general equation. But then when they give you specifics for z, x, and y, then that allows you to solve for k, and now you have the specific equation. All right.
Okay, we'll do number 4, I guess.
Okay. Yeah, no, that we should, because we got to make sure you get this, because this is not really that hard. It's always the same. You just have to know how to write the general equation. So, let's write the general equation from their very first sentence, ignoring the rest of it for the moment. R? You give it to me.
Oh, okay, I don't know if I remember. R very...
What's vary mean?
Means it equals jointly as s the square of t. I guess,
What's the one letter that's in all of these?
I guess t squared.
Hold on. What's the one letter? Always start it with your K. It doesn't matter how it varies. It starts with K. If it varies inversely, then K is going to be right there, and I'm going to have a denominator. If it varies directly, K is going to be right there, and I'm going to have something that's multiplied by.
Yeah.
Well, this varies jointly. That means it varies with two different variables that are being multiplied together.
Okay.
So I know that this is S, and this is the square of t. Well, that's the square of t. So there's your general for this particular model.
Okay.
And that's where you have to start. You got to start with the general. Okay? Now, the next sentence is going to give me two of these three variables. Or, excuse me, it's going to give me all three of them. It gives me R, gives me S, gives me T. What's that going to allow me to solve for?
Okay.
All right, let's do it. You got, in fact, you got it all here. Not quite. You've left out the K from your answer.
25.2 equals A and 9 and 81.
Hold it, isn't it? Oh.
It would be 9 squared.
Ah, it's 3 squared. Okay. So it'd be 0.4 times 9. That should be 3.
Oh, 3 squared. Right.
3.6.
Wait.
Okay, here's what we got. 25.2 equals K, always start with that so you don't forget it, times 0.4 times 3 squared. Now solve that equation for K. That's always the process.
Okay, so then you go like 9 times 0.4, and you
can put that into your calculator like that in one step.
Yeah, that's what I'm doing. It's
Okay.
The answer is 7.
What is the answer?
7.
Perfect, 7?
Yeah.
Now, what's the specific equation? In other words, all we did was we're only halfway through. We've solved for K.
It would be R equals 7s t squared.
Right. Now it's saying, so find R when S is 0.7 and T is 9. So tell me what to write.
Okay, so then you just like plug in all the
Tell me what to write, Sam. You're reluctant to do that, and I kind of want to force you out of that.
R equals 7, 0.7, and then 9.
No? Then 9 squared.
Okay.
Because it's T squared. Okay. Now, that's pretty easy to calculate. That's 7 times 0.7 times 81, whatever that number is.
That's 396.9.
Okay. That's how you do them. You realize, understand that it's the same method every single time no matter how they do it. The entire problem rests in your ability to do that, right there.
Yeah.
And to formulate the general. And you have to start there. There's no other place to start. Okay? All right. And we're going down to 5. Up or up, probably. There's I see a 6.
I mentioned problems up there, like from 5. I didn't miss 5, okay, and 6. I think I missed 6.
Okay, you lost a couple points on 6. Let's talk about 6. All right, we got vertical asymptotes at plus and minus 5. Got horizontal asymptotes at 0. That's why you lost 2 points on it.
Yeah, I think we can just go there.
Well, let's not skip over this too much. Let's talk about your horizontal asymptotes. There's only 3 situations where you have horizontal asymptotes. Okay? Here's one of them. Now, hold on. You need to know this. It's a key thing in math. If you have x over x squared plus 2x, something like that, you take the degree in the highest degree in the numerator, which in this case is a 1, the highest degree in the denominator, which is a 2. If the denominator is greater, then it's always y equals 0, is the horizontal asymptote. If it's the same, let's say this was an x squared, then the horizontal asymptote is the ratio of those coefficients, which is 1 over 1. Can you still hear me? Okay, Sam?
Yeah.
Okay, sorry. I think we maybe had a little interference on our line there. And that's the only real two situations you're going to be faced with. If the numerator is greater than the denominator, then you have to divide it out and do a lot more math. So just remember these two situations. If the bottom is bigger, and in this case it is, x squared is bigger than no x at all, that means your horizontal asymptote's automatically at 0. But even if I had an x up there, it would still be at 0. But if I had an x squared, where would it be?
It would be 0. No.
Ratio the coefficients.
X.
It would be, well, this coefficient is 4, this coefficient is 1. And in fact, that coefficient is negative 4. So the ratio of the coefficients would be minus 4. So that's the way you get your horizontal asymptote. It's relatively straightforward. There's really only two situations. It's either at 0 or it's at these ratio of the coefficients if the power of the x, the highest term x, is the same. We don't care about the lower term ones. The only thing that matters for horizontal asymptote is the highest degree polynomial in the numerator and the denominator.
Wow.
All right. So your curve is close. It's only off by a marginal amount. That dotted line you have there should be down on the x-axis.
Okay, that makes sense. Could you, here, I know which one we have to do next.
Okay.
I think we're done with this page.
Okay.
Could you just go back to the email that my mom sent me?
Uh-huh.
And, just, click on the far right document there.
Just to click on it or open it up?
Open it up, yeah, because this is, wait, no, this isn't the right one. Here, I think it might be back in, I was looking for the quiz on 9.5 and 9.6.
Alright,
So
let me search for your name because all of the ones she sends me. What's that?
The document that we were just in, actually.
Oh, it is in the same document?
Yeah, probably. If it's not in that one that we just checked.
That was the one on the left, right?
Yeah.
Okay. No? This is 12.3 and 12.5.
No, but this is a huge document, so just keep like scrolling down until you see the quick quiz on 9.5 and 9.6. If it's not there, I can like text you a picture so we can just look at it.
It's like there's a lot of stuff we need to cover on the logs.
Yeah, I think we already did all those corrections. So.
Oh, okay. All right. So this is where we were at, and that's at the bottom. So there's nothing else on this one.
Try that middle document, the one that we haven't looked at.
All right.
Yeah, it's just, I don't know, we've done a lot of the corrections. It's just hard to find.
Do you have a copy of these in front of you?
Yeah, I'm looking at it right now.
Okay.
I can get a picture of it if we... All this text to your phone and...
Don't text it to my phone. I don't have anything I can do with it on my phone. You got to send it to my email. I can't even forward it. My phone operating system can't be updated, and it's not letting me do certain things.
Okay. Oh.
Do you have my email?
Yeah.
David Cowan 1949 at gmail.com.
I'm gonna...
Okay.
David Cowan 1949.
Let me write it. Make sure you don't misspell it. because you don't want to misspell it, because then you end up with two of them stuck in your phone and you never know which one's the correct one. I've had numerous students do that. They spell it A-N one time and E-N the next, and then when they go back to do it the next time, they don't know which one to choose. I guess if you knew how to delete your or edit your default list, you could fix it. But
okay, here I
tell me when it's sent. Well, tell me when it says sent on your end.
okay. Here, just refresh it again because it's on my phone and it's
There it is. You may need to send it as a large image. You send it as a small image.
okay. Let's read it.
Are you using an iPhone?
Yeah.
Yeah, I recognize this problem. This happens a lot. Just need to make sure if you send it as a large image, it'll be crystal clear.
Okay. It might take longer than that.
Ah, because it's a large image. Maybe. We'll see. Tell me when it says sent on your end and we'll time it. Ah, there it is. There it is. Didn't take that much longer, did it?
Yes.
Well, I'm curious whether there's, it's got to be more pixels and data in this one than the previous one. That's why we couldn't see it, as it wasn't high enough resolution. So you're probably right. Probably did take longer to send this one. So we're starting on 1.
Yeah, let's start at 1.
Okay. Let me see how much I can zoom in. Now, should I check your work first, or?
Sure, yeah, just check my work, see where I messed up, because it'll take a while to do that.
Well, I can write directly on this. So here, let me first pull it up. So if I note something that looks funny, I'll say so. Okay, so here you're finding a common denominator. Does that numerator say x plus 1?
Yeah.
Okay, so now I've got 6x plus 6. Okay, and now since the denominators are the same, you operate on the numerators. That's probably the first step you should do.
Hey, what about question number 1?
Oh, sorry. After I blew it up, sorry. When I blew it up, it kept it in the top left screen, and then I forgot that it changed the number on it. Oh, geez, hold on a second. Sorry.
Yeah, it's okay. Whatever.
All right. Yeah, when I blew it up, it took, and there. I got to blow it up in order to, okay. Now we should be good. Okay, can I see what you're doing? Not really. Yeah, maybe. Here, let's see. In other words, I'm not seeing this far left part. But clearly you're going to find a common denominator. Operate on top. here's what you want to do on these, Sam, is treat them completely separately. In other words, you solve that, and then you solve this. You have a single rational quotient divided by another single rational quotient. That's the way we're going to do all of these. Okay? So, we got x minus 3 over 4x. Common denominator is going to be 4x, which means I multiply this by x, and I'll write it like that just for understanding's sake. Now let's solve this. So we get x minus 3 minus x squared. What's the next term?
Minus 3x.
No. That's where you made your mistake. This minus has to go to that minus. In other words, I am subtracting this entire thing. So that minus sign has to be distributed to all of these terms. I've already distributed it to the x squared. That's why it's minus x squared, but it's plus 3. Now the 3's cancel, and that's our new numerator, x minus x squared. Okay? Now, let's look at the denominator. The denominator is what's this left term become? I think you're all right with this, so let me go ahead and write it out. I'm multiplying top and bottom by 5 to get a common denominator, and then I'm subtracting x minus 3 over 25, so that's going to give me 20x, and you're going to have the same problem here. What's the next two terms?
Yeah, I'm just writing this one down. Okay. The next two terms would be minus x plus 3.
Which gives you 19x plus 3 divided by 25. Okay, so now I put the two answers together. Here's what I got. My numerator still has a 4x in the denominator. So it's x minus x squared over 4x. Correct? Yeah. In other words, when I added those two together, I didn't lose my denominator. I just forgot to write it.
Yeah.
Okay. So that's my new numerator. I make sure my fraction bar is bigger. You always want the middle fraction bar to be the longest so you can tell what you're looking at. And then the bottom is this. My answer over there. And now, how do you divide a fraction by a fraction?
Common denominator.
You flip and multiply. So I'm going to multiply that by 25 over 19x plus 3. So let's do that math. What's that give you?
I'm just writing this down and what we have.
Okay. In other words, we got to multiply those two terms and we'll have our answer.
Okay. So then you do 9x. You have 25x minus 25 squared.
Okay. Kind of customary to put the largest term in front. So we'll rearrange it after we're done. Go ahead. Now what do you got on the bottom?
You have 76x
Squared.
on the bottom plus 3. No, plus 12.
Plus 12x. You're forgetting the x. It was 76x squared, because it's 4x times 19x, plus 4x times 3. Now, I can simplify this.
You can multiply the bottom one to the top, I guess.
No, we're done except for simplification.
Yeah, you can.
Take a greatest common factor out of the numerator. What do you get?
12.
Look at the numerator only.
Oh, you mean numerator. Okay, my bad.
What's the greatest common factor I can take out of that? In other words, in order to simplify this, I can see that I got at least an x in every single term. So I know I can divide everything by x and reduce that. But let's do it proper. We're going to take out the greatest common factor out of the numerator, and that's going to leave 1 minus x, correct?
Yeah.
Okay. Now, out of the denominator, take out the greatest common factor.
That would be 12.
Oh, I can divide every, no,
12x.
12 goes into 76 evenly? I don't think so.
Actually, yeah, you're right. Okay.
But I know I can divide everything by 4, because this was 4 times 19, so I'm going to take a 4x out, leaving 19x plus 3.
Okay.
Now, interesting, because at some point I was in that step right there. And notice that I already had the bottom factored. I never should have multiplied those two together. And there's a lesson to be learned there. Notice that I had you multiply 4x times that to get that, and then we had to refactor it. Well, we should have left it factored in the first place. Because now the problem is the numerator did need to be multiplied out before it could really be factored. So sometimes you have to multiply it out, but other times you don't. And now I can simplify by crossing off that x with that x, because there's only multiplication going on. And so therefore I can cross those x's out, and my final answer should be, and you can definitely leave this in factored form, 1 minus x in the numerator, and in the denominator, 4 times 19x plus 3. That's an okay answer. There's numerous answers. You can multiply these numbers back also. In fact, she probably wants you to. Her answer is probably going to be 25 minus 25x all divided by 76x plus 12. Almost certainly. Yeah, let me say a further thing on that. If you have variables in both factors, then leave it factored. If you have a number as one of the factors, then usually multiply it back together. All right, what next?
Let's do number 5. And then, actually, let's do number 2, because I just feel like number 2 is quick, so.
Okay, yeah, number 2 isn't bad at all. Hold on, let me look at it first. Maybe I can spot the error. You only lost 1 point on it?
Yeah.
Well, I can spot it. This is part of it down here, right? You got a plus 2x minus 5x. You ended up getting minus 7x, and she corrected it to minus 3x. So why did you have the wrong sign on the 2x? Let's see if we go backwards here. You got a plus 2x up here. Well, I guess the only way I can do it is to go through it.
That's fine. He gave me the right answer for that.
Okay, well, let's go through it then, which means I need to take a picture of it and be able to write on it. All right, so here's the way I do it, and I highly recommend you do it this way. And down here, you write your least common denominator, which is What is the least common denominator here?
The least common denominator. It's just that multiplied by that. There are 2.
Tell me the numbers, Sam.
X plus 7 and 6 plus 1 equals
6x plus 1.
Yeah, 6x.
Okay. So I write that in both spots and I leave it not multiplied together. No need to multiply it together yet. There's a reason to leave it factored, a really good reason. What's the numerator going to be up here?
The numerator
on the upper left, yeah.
The numerator is going to be 2x times negative 5.
Not negative 5. First of all, I've got to make sure that this fraction that I'm writing is identical to that fraction. If I've changed it, I've made a mistake. Excuse me, that's a 1. Okay? Now, is it the same?
Yeah.
And I can see it easily because I left everything factored. Had I multiplied this out on the bottom and the top, well, it would have been much harder to figure out what this numerator should be. But when you do it like this, you can instantly check. Okay? Now, what's my numerator over here on the right? It's 5 times what?
5 times x plus 7.
Right. And I can instantly tell that that's exactly what I started with. Okay? Now I can already tell you what your mistake's going to be that you made on here. This subtraction sign needs to be applied to the minus 5 or to the 5x that you're going to get and also to the 35 that you're going to get. So the 35 is going to be negative. And I can see up here that you've made it positive.
Yeah.
So that's where the mistake is. Same mistake as you made on the previous one. So, boy, all you got to do is fix this one mistake and it's going to allow you to get all these problems correct. But if you keep making it, you're going to miss every single one of them. You cannot make that mistake. So the key is when you subtract two fractions like this, use parentheses. In other words, once you convert that to a 5x plus 35, put it in parentheses. I mean, even if you go ahead and multiply it together, which you do at some point, it's got to be 5x plus 35. If I don't use parentheses, I'm going to make the mistake you made. But if I use parentheses, I won't. I could use parentheses over here on the left, but I don't really need to. There's no mistakes you can make by not using parentheses on the left. I mean, once I multiply those two together. Do we need to, we probably don't need to go through the rest of the problem because that's clearly what happened.
Yeah, we should go through number 5.
All right. All right. Well, they got a negative sign. I can already tell you what your mistake's going to be.
Yeah.
You're going to end up with a minus 5 instead of a plus 5. Or whatever. I'm sorry, I forgot. We're multiplying that by that. But after you do that multiplication, put parentheses around it so that that minus sign gets applied to every term that's in that numerator.
Yeah.
That's all you have to do to fix your problem here.
Okay, here, I'm going to write it down. R squared minus 7 plus 6. R squared plus 6.
I'm happy to go through it with you if you want. You want me to write it on here?
Yes, please.
We'll go through it step by step, but in other words, you've made that mistake twice. I'm sure you're going to make it here. So here's what the right side becomes. Okay? Just going to multiply the right side out in parentheses. So that's going to become r squared plus 3r minus 5r is minus 2r minus 15. Now the fact that I put parentheses around it means this minus sign gets applied to all three terms. The bottom is r squared plus 3r. So now we've got this over here on the left minus what I have in parentheses there. So what is that? The r squares cancel. I've got a total of how many r?
I have a total of 1 r.
You got minus 7 over here, and you got a minus 2 there. That's plus 2. So we got minus 7 plus 2. We got minus 5r. Now, how many numbers do we got? We got 6 minus a minus 15. That's plus 21. There is our numerator. Our denominator is still r squared plus 3r.
That's it done.
What's that?
That's the finished one?
Yeah, I don't see how we can separate that. I could factor an r out from the bottom, but it doesn't do any good. In other words, you only really want to factor if it does good. If I could factor an r out from the top and the bottom, then I would do it, because then I could cross them out against one another. I can't take any numbers out. There's nothing that divides into 5, 21, and 3. So there's not much I can do. I could reverse the order of the numerator, make it 21 minus 5r, but don't see a reason to do that. Okay. Now the one thing you could not do is move that negative sign out in front.
Okay.
Because that negative sign is not operating on that 21. And the moment if I were to move it out in front, it would have to operate on the 5r and the 21. I don't want it to. So leave that negative sign in the numerator. And maybe that'd be a better way to write it this way, just so we don't have that problem. Although, I don't know. I like having the variables in front, not after the constant. When you go up in math, you usually always, your first term is the highest degree variable, and then the next highest degree variable, and then the constant. So the constant's almost always at the right. All right.
Okay. The only thing I have left to correct right now is one place, but like it's really easy to correct because it was like just on radians and stuff.
Okay. Can you verbalize it?
Yeah, I guess so. But then I'm going to be getting like a couple things back. You can have it. Like a test that I took that I really need to correct.
Go ahead and verbalize it if you haven't sent it.
Okay, I missed the tangent of 135.
Okay. What's the reference angle?
The reference angle is 135. The reference angle would be.
The reference angle means the same thing as what's the equivalent first quadrant angle?
225.
No.
Negative 225.
No. Hold on. Here's your unit circle. Here's the formulas you use. 180 minus theta if you're in the second quadrant. theta minus 180 if you're in the third, and 360 minus theta if you're in the fourth. So what's the what quadrant are we in?
Second.
Okay, so what formula, what's the reference angle?
45.
Now, what's the tangent of 45?
It's 1.
And what is its plus or minus sign in the second quadrant? Because we have all students take calculus.
It would be -1.
That's the answer, and that's the way you do it. And always do it that way. In other words, one thing I notice about your work is you kind of got scribbling all over every problem. And it's, when I say scribbling, it's not in an easy to follow step-by-step format. And that's going to make it hard for you. The best way to do math is repetitiously. Figure out a way to do a problem and then do it that way every single time. What's the next question? What sign, or what are the next? I'm going to do it exactly the same way, regardless of what problem you give me. Go ahead.
Okay, this one's going to be a little weird to find, but it has the radian, like, unit circle coordinates, so the cosine of root 3 over 2 is the sine of -1/2.
Okay.
And we have to find, like, the radians and degrees.
So that's the coordinate point at the end of the ray, right?
Yeah.
Okay. What quadrant's that in?
Sine is, y. So
Well, just read the coordinates. The x-coordinate's positive, the y-coordinate's negative. Which quadrant does that place it in?
it has to be in the fourth quadrant.
Correct. So we're looking at a fourth quadrant angle. Okay? Now, if I draw that angle, they're saying the cosine of this angle, there's the reference angle, is square root of 3 over 2. Well, what angle is the cosine, what angle is the cosine of that angle equal to square root of 3 over 2?
330.
Right, or 30. We're talking about the reference angle. Let's keep everything small. Okay? Now, what that means is, since that's the reference angle, the original angle is that's a -30 there, which makes the original angle 330. So, yeah, either, you actually can answer this in both ways. You can say it's a -30 degree angle, or you can say it's a 330 degree angle. All coterminal angles are equal. 360 is the same as 720 in terms of trig. I mean, it may not be equal with other respects, but in terms of the trig answers, they're equal.
Yeah.
Since we were working with the reference angle, in other words, we didn't know how to really find the cosine of 330. We do, but you'd have to take it back to a 30-degree reference angle anyway. But it's always best to work with that reference angle, because that's an acute angle less than 90 degrees, no matter which quadrant you're in.
Yeah.
Okay? What else?
The tangent of -150.
Tangent of -150?
Yeah.
Okay. And I'm using parentheses because of the negative sign, but there's two ways to do this problem. There's really the easy way and the hard way. I'm going to do the easy way. recognize the property of tangent. That if you take the tangent of a negative angle, it's the same as the negative tangent of the positive angle. Now, let's work with this 150 degrees and we'll end up with the correct answer. What's the reference angle for 150 degrees? No. Second quadrant.
Angle of 210 in that quadrant, so that means 360 minus 210. And that would be 210.
Okay, you're doing it the hard way is the problem.
It would be 30.
Okay. Doing it the easy way is 30. Doing it the hard way, you would convert that to 210, and then we'd be dealing with the positive tangent of 210, which is definitely a third quadrant. Still gives you a reference angle of 30. But that's the hard way, and I'll show you why. The way you were doing it is actually 2 steps longer than this way.
Yeah.
Now, what's the tangent of 30?
The tangent of 30 is negative. It's going to be root 3 over 3.
And the way I'm doing it, that's a second quadrant angle, 150. So that'd be negative, right?
Yeah, good point.
But now I've got that negative and that negative become a positive. So I end up with the right answer. I just did it a slightly different way. Here's the way you wanted to do it. You wanted to take the coterminal angle, and this is actually the way I always did it in the past. It's just I realized that it's an extra step. Now the reference angle is still 30, so I still get root 3 over 3, only now I'm in the third quadrant, so I know it's positive. So I get the same answer. And it actually looked like it was a little easier to do it your way. And it can look that way if it's in the third quadrant. But if it's in the fourth quadrant, it's far easier to do it my way. But you do have to remember the odd-even properties of tangent and sine and cosine to do it my way. You got to know that the tangent of a negative angle is minus the tangent of the positive angle. Because that's not true with cosine. Cosine of negative x is cosine of 30. No negative sign at all. Positive cosine at 30. So you got to know which functions are odd and which ones are even. Sam, you good to go?
Yeah, thank you.
You're welcome. I'll talk to you on Thursday. I think we have another 7:30 on Thursday.
Yeah, I think so too.
Okay, bye-bye.